Weighted averages is when you're combining two things to make another. They're also known as mixture problems. And then you also have like the uniform motion problems. So you have mixture and uniform motion. You guys have heard the uniform motion problems? Those are the ones that you see on movies where like the train leaves the station at such and such time, traveling in opposite directions, blah, blah, blah. Those are uniform motion problems. Weighted averages are mixtures. Application-wise, these weighted averages have applications in science and business. The first example is a business one. So I should keep recording. To make blackberry tea, dried blackberries that cost $10.50 per pound are blended with black tea that costs $35 per pound. How many pounds of black tea are added to 5 pounds of dried blackberries to make blackberry tea? That's a lot of information. The best way to organize this information is in a table. And the table will help you because it organizes the information and it also creates the equation for you. Okay, so we have black tea. We have blackberries. And then we have a blended tea. Okay, so we have black tea plus blackberries gives us blended tea. We have the price per unit. So that's per pound. And then we have the number of units. And then we have the total cost. Now to find this total cost, we do, if this is column 1 and this is column 2, this is column 1 times column 2. Gives us column 3. Okay. Black tea. Black tea costs $35 per pound, so $35. Blackberries cost $10.50 per pound. And then the blended tea is $25 per pound. Okay, so that's our price per pound. The number of units. We have 5 pounds of blackberries. That's the only one that they gave us the number of pounds on. So that goes here, 5 pounds. I'm trying to find how many pounds of black tea. So if I come, I meant to write these in white. Hold on, I'll fix that so you can see it better. It'll be the same numbers, don't worry. So this was 35, this was 10.50, this was 25, this was 5 pounds. We're trying to find how many pounds. So since that's our unknown, we'll call it X. Okay. Now, when we add 5 pounds, we're going to end up with blended tea. We're going to have 5 pounds of blackberries, and then we're going to have some black tea, and we're going to put it together, and we're going to end up with blended tea, and we're going to take those 2 amounts and put them in a pot together or whatever, so they're going to get added together. So with this row, you're going to add down. Okay. Then I multiply across. So 35 times X, 5 times 10.50, which I'll get that total in a second, and then 25 times X plus 5. Okay. I'm gonna pull up my handy dandy cheating tool. So 5 times 10.50. So this will be 52.50. Or, well, I'm going to leave this just 52.5, and then I distribute this 25. So this becomes 25x plus 125. Okay. Now again, I'm going to add down. So in this first row, the price per unit, I don't add down because obviously these two things don't equal 25. But in row 2 and row 3, or sorry, column 2 and column 3, I'm going to add down. So I add these to get the total number of pounds, and then I'll add these to get my equation. This is my equation. So 35x plus 52.5 is going to equal 25x plus 125. So this plus this equals that. Now that I've set up the equation, I'm going to solve it. So I subtract 25x from both sides to get 10x plus 52.5 is equal to 125. I'm going to subtract 52.5 from both sides.
Slow it down just a second.
Sure.
So I can write this down.
No problem. Well, okay, so then I get 10x is equal to 72.5. Divide both sides by 10. X is going to be 7.25 pounds. So in order to make this tea company would take 5 pounds of blackberries that cost $10.50 a pound and mix it with 7 1/4 pounds of black tea, and then they would develop a product that costs $25 per pound. Yeah, maybe. Okay, so premium coffee beans should be mixed with supreme coffee beans to make a blended coffee. So we have premium, supreme. Did I spell that right?
Did you forget the money sign in front of 11.75 per pound?
Yes.
Okay.
And then we have the blend. This is the price per unit. This is the number of units. And these are my totals. Okay. Now remember, we're gonna take this column times that column will equal this column. And then on these two columns, this plus this equals that. This plus this equals that. Does that help? So here we move down, down, and there we're moving across. All right, so the premium coffee is $9.50 per pound. The supreme coffee is $11.75 per pound. And we want the blend to be $10 per pound. Okay, how many pounds of premium coffee should be mixed with 2 pounds of supreme? So we have 2 pounds of supreme. We don't know how many pounds of premium, so we're going to call that X. And then we'll get however many X was plus 2 pounds of the blend. And I mean, that kind of makes sense, right? If I have 5 pounds and then 2 pounds, I'll get 7. So I'm adding them together. We multiply across, so 950 times X. 1175 times 2. So 2350. And then I'm going to add, oh, sorry, multiply across. 10 plus, sorry, 10x plus 20. This is my equation. That last column is my equation. So 9.5x plus 23.5 is going to give me 10x plus 20. Just to keep everything, nice and positive, I'm going to subtract 9.5x from both sides. So get 23.5 is equal to 0.5x plus 20. Subtract that 20. Move to where I have more space. 3.5x is equal to 3.5, no x. Sorry, don't mean to be confusing. 3.5 is equal to 0.5x. Divide by 0.5. And I think 7, yeah. So X is 7 pounds. All right, we have pineapple juice punch, and we want some we have some 3% punch, and we have some 33% punch, and we want 20% punch. Okay, and these are the same as if we were mixing acids. You can like dilute acids in chemistry lab, like if you have some acid that's a 3% acid and some acid that's a 33% acid and you need something in between. Okay, we have the number of units, and then we have the total. Now the reason I don't have an extra column here, I could put an extra column in here, but the reason I didn't is because the column I would use would be this percent column. So I'm just going to convert these percents to decimals. I have a 0.03, a 0.33, and a 0.2. Any questions on how I went from the percent to the decimal? Okay. I'm going to multiply this percent. The total is going to be percent times number of units. Gives me that total column. No, she has 16 cups of the 3%. So here's 16 cups. And she has punch that is 33%, and she wants to make a 20%. So I don't know how much of this to use. And this would be 16 plus X, or X plus 16, however you wanted to write it. Does that make sense? This would have been like our price per unit, except we're not having a price, we're having a percentage. So you can make an extra column for the percentage if you want to. I usually just, it's already in the name, so I just kind of leave it there, and I make less columns that way. So I'm going to do 16 times 0.03 to get this number, 0.33 times X, and then 0.2 times X plus 6 to get this number. And then that's going to be 0.2x plus, I think that's going to be 1.2. I filled out the chart, and so this plus this equals that. So 0.10548 plus 0.33x equals 0.2x plus 1.2. Don't let the decimals freak out. Yes, of course. So 10548 plus 0.13x is equal to 1.2. Okay, and then divide both sides by 0.13. So 8.4 cups. So if you have some juice that's 3%, or some punch that's 3% pineapple juice, and you want to mix it with 33% pineapple juice to make 20% pineapple juice, you would take 16 cups of 3% plus 8.4 cups of 33% to get 20%. So here we have antifreeze. Okay, so antifreeze, you've got the different types of antifreeze for different kinds of cars. You've got like the pink stuff and then the green stuff or whatever. Well, maybe you have a car that needs a mixture of the two. So we have 40% glycol, 60% glycol, and we want 48% glycol. Okay, so in this column I'm going to put the percent, in this column I'm going to put the units, and in this column I'm going to put the totals. Remembering that I'm going to add down and multiply across. Okay, in this first column I'm just going to convert the percents to a decimal because I can't multiply by percentages. So 0.4, 0.6, and 0.48. All right, I have 100 gallons. I want 100 gallons of 48%. So I'm actually getting the total, not the parts. So you choose, which one of these do you want to be X? The 40 or the 60?
40.
Okay, so we'll make this X. If I have some amount of X and I add it to something else and it equals 100, to find out what this is, I would subtract X from it. So if they give you the total amount that you want at the end, you subtract. If they give you the starting part, then you add. Does that make sense? Because then if I do X plus 100 minus X, I get 100. Okay. So then I'm going to multiply across, so I get 0.4X. I'll just put this off to the side. So I get 60 minus 0.6x when I distribute that 0.6, and then 48, because 100 times 0.48 is 48. And again, here's my equation. This is the good column. This is the one we want to work with. So 0.4x plus 60 minus 0.6x is equal to 48. 0.4 minus 0.6 is going to be a negative 0.2. And since they're on the same side, that's why I just combine them. I'm going to subtract 60 from both sides. So I get negative 0.2x is equal to negative 12. Divide by that negative 0.2. All right, so 60 gallons of the 40%. But it said how much of each kind, so I have to say 60 gallons of the 40%. So if I have 60 gallons of the 40%, how many of the other one do I have? To make 100. 40. Yeah, so I'd have 40 of one and 60 of the other. It's still a weighted average. Those were mixtures. These are uniform motion. And those are like rate you use the distance formula. Distance equals rate times time. Easiest way I can think of it is this is dirt, and you go the distance on the dirt. Okay. There's two types of uniform motion problems. You have the speed of one vehicle and you have the speed of two vehicles. So with one vehicle, it's usually you go and then you come back. With two vehicles, you're moving towards each other or moving away from each other. I like to draw pictures for these. That's just my personal way to do it, but we could also make a table, so I'll do both. See, okay, it took Travis and Tony 40 minutes to skate 5 miles. Okay, so they start here and they go 5 miles, and it takes them 40 minutes. But then they turn around and they come back and it takes them 30 minutes. Okay, this is their time, this is their distance. What we don't know is their average speed. Now there are two ways to work this problem. Okay, you can consider it that they're going 10 miles in 70 minutes and work it that way, or you can work it in the two parts, and that the distance of the first trip is equal to the distance of the second trip. Okay. So we're going to talk 10 miles in 70 minutes, and we want to find their average speed. Speed is typically in miles per hour. So we're going to convert this 70 minutes into hours. Well, there are 60 minutes in an hour, so it'll be 70 over 60, which would be 7/6. And you can just leave it like that for now. Okay. Distance is equal to rate times time. My distance is 10 miles. I don't know my rate, and it took me 7/6 of an hour. So far, okay? So I want to get rid of this 7/6, so I can multiply both sides by 6 to cancel, if you like that two-step way. And I got 60 is equal to 7r. Divide both sides by 7. And I get 8.57, so we'll say 8.6 miles per hour. That's their average speed, right? So this other method, it's not a pretty line, I want a pretty line, involves comparing the two trips. Distance 1 is equal to distance 2. So I have two formulas. I have distance 1 is equal to rate times 40 minutes. Well, so that would be 40 over 60. So 4 over 6. And distance 2 is equal to rate times 3 over 6. But the distances are the same, so I get 4/6r is equal to, no wait, that won't work. How many times did I do this? Okay, the distances are the same, right? So the distance plus the distance is equal to the total distance, which is 10 miles. And so when you do it this way, you're going to take your first distance, which is 5, is equal to 40 over 60r, and 5 is equal to 30 over 60r. When we reduce these, we're going to get 1/2 r plus 1/2 r. That doesn't make sense either. You know, ignore me. This is uniform motion, one vehicle. You are your vehicle at this point. If you're jogging, you are considered to be the vehicle because you are moving yourself. So we start and we go 2.5 miles. And we do it in 16 minutes. And then we go 1 mile in 10 minutes. And we want to find its average speed. Well, what's our distance?
3.5 miles.
Yeah, 2.5 plus 1, so we get 3.5 miles. And our time is going to be that 16 plus 10 to give me 26 minutes, which is equal to 26 over 60, which I can reduce to 13 over 30. Right? Any problem with the reduction? You don't have to reduce it. You can use the 26 over 60. You'll just be multiplying a bigger number. So my distance is equal to my rate times my time. My distance was 3.5. My rate is unknown, and my time is 13 over 30. I'll multiply both sides by 30. So you get 105 is equal to 13r. Divide by 13. .1 miles per hour. So this guy was walking just as fast as these guys were skating, just about. These are fun. All right, I like to draw. So I've got train A, and I've got train B. So this is A, and this is B, and they're traveling towards each other. Train A is going 35 miles per hour, and train B is going 45 miles per hour. They are currently 550 miles apart, and I want to know when they're going to pass each other. So basically when they'll meet.
They're not.
Why wouldn't they?
Because the one in front is going 45 miles per hour, and the one in the back.
No, they're traveling towards each other.
Oh.
Yeah, traveling towards each other. So this one's going this way, and this one's going this way, and at some point they'll meet.
You just drew A backwards, that's all.
No, it's traveling east, and train B is traveling west.
Oh.
Oh, I guess I put the smokestack on the wrong side. Right? The smokestack, oh, whatever. My smokestacks are in the front. With my trains, I designed them. Yes. So we want to know, when is this going to happen? When is this meeting point going to occur? So this one has distance equals rate times time, and this one has a distance equals rate times time, and they make a total distance of 550 miles per hour, right? So the rate and time of train A plus the rate and time of train B is going to equal that 550. It'll be the same time though. Does that make sense? Because they're going to meet, so it's at the same time. So I have 35t plus 45t is equal to 550. So this is 80t is equal to 550. Divide both sides by 80. And t is going to be 875 hours. This one's a little different. So we're going to start at one point, okay? And one person's going to go this way on their bicycle. And the other person's going to go this way on their bicycle. Stick figure bicycles. Oh, wait. Circular. I should read the problem correctly. I have to draw a circle. Bicycle trail, 5 miles long. Okay, one bicycle goes this way. The other bicycle goes this way. How long before they meet? Okay, this bicycle is going 12 miles per hour. And this bicycle is going 18 miles per hour. When they meet, that means the time will be the same for both bicycles, correct? And the total distance is 5 miles total. So again, this is going to be a first bike plus a second bike equals the whole distance. Okay, bike 1 plus bike 2 equals the whole distance. So I get 30t equals 5. Divide both sides by 30. And t equals 1/6 of an hour. And if you wanted to, you could say that's 10 minutes.